Hi everyone, and welcome back to the second part of this. So today we're going to be looking at defining circular functions and actually seeing just where they actually come from and all those sorts of things. So you can see I've already got my unit circle drawn up here. Now, the first thing that we need to know is the definitions for sine and cos. Now they come from, if we were to pick any point on the circle, so I'm going to pick this point just here. Ah, that's interesting. So if I put that point there on the circle, okay, I can actually get the coordinates of that point. So I'll just draw a dotted line going out there. Okay, now we know that distance is 1 because, again, it's the unit circle which has a radius of 1. We've turned through an angle theta, which we can mark just here. Okay, and this point has both an x and a y coordinate. So if we have a look at the x coordinate down here, we can see that it's going to be whatever that distance there happens to be. And, well, it doesn't really matter what that distance is, but we define it as being cos theta. Now, the other coordinate that is important here is the y coordinate, and so the y coordinate of this point we can see we would get by measuring back across to the y axis here. We would get some y coordinate, and it's going to be whatever that height happens to be, and we defined that as sine theta. So it's easiest to remember that the y value is always given just by sine theta and the x value is always given by cos theta. Now the other value that we need to get comes from the unit circle as well. So this is the value of tan theta. And tan theta actually is based on what we call a tangent line. So it lies tangent to the curve of the unit circle. It is parallel to the y-axis, and it is an imaginary line that runs along the side of the circle like that. It always runs along the right-hand side. And the way that we get the tan value is we actually, well, we went through this angle and we took it out to this point here, and if we continue drawing that out, we're going to reach a point up here. Now this point has some kind of height to it. Okay, we know that the x coordinate is always going to be 1, so that's not what we're measuring the height. And the height of this is going to be our tan value. So I'll just mark that as tan theta. So we can actually prove, I mean, you probably know the rule already saying that tan theta is sine over cos, and we can actually prove that using similar triangles. So if I have a look at my first triangle here, it has the values of sine and cos on the two shorter legs of the triangle. The larger triangle, okay, this one here, has 1 along this side of it and has tan theta along that side. Now I can actually write out a ratio comparing these. So I can say tan theta in ratio to, now the tan theta would compare to this side here, which is sine theta. So tan theta to sine theta equals, and I'm going back to the larger triangle now, so the base of that is 1 in ratio with the smaller triangle which had a side length of cos theta. Now you might know that the ratio sign just means divide, so I can actually write tan theta over sine theta equals 1 over cos theta, which can quite simply be rearranged to say tan theta equals sine theta over cos theta. So we just do that by multiplying by sine theta on both sides of the equation. And so this is our definition for tan theta, and I think that this is quite an important rule to remember. So we need to know that tan theta is sine theta over cos theta. We also need to know that sine is the y value and that cos is